we had previously looked at some examples of sequences. Now, what we look at are of the first few terms of a sequence. Let me look at what they were again. I had 1, 2, 3, 4, 5, 2, 4, 6, 8, 10, 12. Let me just write that down. I wanted to keep that screen here, but the software had stopped suddenly, so I have to rewrite those numbers. We had 1, 2, 3, 4, 5, and so on and so forth. 2, 4, 6, 8, 10, 12, and so on and so forth. And what was the other one again? The other one, 4, 9, 16, 25, 36. 4, 9, 16, 25, 36. 4, 9, 16, 25, 36. So these are 3 examples of sequences that we looked at. Now, generally, how do you write the nth term of a sequence? The thing is, when you write the nth term of a sequence, you get a function that shows you how to get the term in the first position, the term in the second position, the third term, the fourth term, the 100th term, the 1000th term, whatever term, you get that function, that expression, which shows you which term you get. Now, the first term is generally referred to as U1, second term, U2, third term, U3, and so on and so forth. As to why the U is used, that's another matter, right? Based on what I've seen, when I looked that up, it probably was due to some major British exam in the past, or a book, a major series of mathematics book that used U as the letter that is used to represent the term. And then after that, everybody had just adopted it. Any letter could have been used, maybe A1, A2, A3, B1, B2, B3, and so on. But I find that in most cases that I found, they use U. Alright, so it goes on and down to the nth term, which is UN. So what you have, U1, the first term, U2, the second term, U3, the third term, and so on. So UN, which is the nth term. Now, that's a general way of writing the term in the particular position that you want them to be. So, let me just erase this and see if I can find out UN equal, what UN is equal to. What is UN equal to for this term? Let's see if we can figure that out. Let me erase this. I might need this space over here. Now, we see that U1 is equal to 1. That's this. U2, the second term, in position number 2, you have U2, which is 2. In the third term, which is position number 3, U3 is 3. U4 is 4. U5 is 5. I would expect that U6 would be 6. And so on. So you can see the pattern here. Basically, UN is just N. Right? UN is N. Now, let me just erase what I have here. Erase some of this thing here. All right. What about this one? Let me draw a line here to separate it from the other pieces of work. What about this? I want to find out what U1 is, U2, what UN is. I can see that U1 is 2, U2 is 4, that's the second term, is 4. U3, the third term, U3 is 6. How about U4? U4 is 8. What is U5? The fifth one. U5 is 10. U6 is 12, and so on. Now, let us try to figure out how these terms came about. Now, let's see if we can figure this out. U1 is 1. Suppose we have the first term, that's position number 1, multiplied by 2, we get 2. Would it work here? In position number 2, if we multiply 2 by 2, we get 4. Well, seems to work for that one. The third term in position number 3, suppose we multiply it by 3. By 2, we get 6. In the fourth position, term number 4, multiplied by 2, we get 8. Seems to be working. In the fifth position, term number 5, multiplied by 2, we get 10. 5 2 is 10. Term number 6, sixth position, 6 by 2 gives you 12. So, I can feel safe saying that in the nth position, term number n by 2 will be 2n. So therefore, I can say with confidence that U6, not U6, UN is equal to 2n for this. Good. So UN is equal to 2n. Let me separate here. So that worked out. What about the third one? Let's make some space by erasing some of what I have here and do some work on that. Let me erase and erase. Now, for this, 4, 9, 16, 25, 36, it is obvious that, let me just put a line here to take these two out. Alright, it is obvious that U1 is 4. First term in position number 1, you have 4. In position 2, the second position, you have 9. The third position, U3 is 16. In the fourth position, U4, you have 25. U5 is 36, and so on. What could possibly be the function that generate these terms, the youth term, the UN? What could UN be? Let's see something. We want UN. Suppose to get the 4. Suppose I say, remember, this is term number 1. So it's 1, and we'll do something to the position to get the term. 1 plus 3 gives you 4. Okay, let's try it here. Term in the second position, 2 plus 3. 2 plus 3 is 5, not 9. No, that won't work. So we have to backtrack. Adding 3 to each will not work. So let's see if we can do something else. Suppose we say first position is 1. 1 by 4 gives you 4. Okay, multiply the first position by 4, you get 4. In the second position, is 9. Position number 2 by 4 gives you 8. Oh, no, not working either. We have to find some other way to figure out what could possibly be the function that generates each term. What could un be? Let's see. Suppose I say to get 1, 2, 4 is 2 squared. Suppose I say the term position number 1 plus 1 squared. That's 2 squared, which is 4. Okay, that's for that. This one, suppose I say the position 1 plus, no, this is the second position. Position number 2, second term, plus 1 squared. This will be 2 plus 1, which is 3 squared, give you 9. Wow, that works. We still have to try now because we want to make sure whether it works for the third one. Suppose I say in the third position you have 3 plus 1 squared. It is 4 squared, which is 16. Seems to be working. If we try 25, it is in the fourth position, position number 4 plus 1 squared, which is 5 squared, which is 25. And in the fifth position, 1, 2, 3, 4, 5, the fifth term, 5 plus 1 squared, which is 6 squared, which is 36. So now we get it. Just take the position number, add 1 to it, and square it. So to get the nth term, it must be n plus 1 all squared. Nice. So the nth term is n plus 1 squared. Good. So the third one wasn't so quick and easy, wasn't as quick and easy as the first and second one, but we eventually got it. So in this case, we looked at the first few terms of a sequence and we're able to figure out what the nth term would be. Alright, so we'll continue looking at sequences in another video, so I'll see you then.